Hey guys, I am going to go through all your questions on your Unit 8 Radicals test. So here we go. Number 1, you basically need to break this thing down off to the side, this square root 45x to the 5th. They want to know, what does this look like completely simplified? So one piece at a time, we're going to do a factor tree on 45. So we could do 9 and 5, and then we could do 3 and 3. So let's go ahead and break that down first. So if I kind of get my answer started, you got a pair of 3s, 3 will come out. That 5 doesn't have a pair, so it stays under. For the x to the 5th, there's always a couple ways to do this. If you got this wrong, this is what I would do. X to the 5th is just x 5 times. So I would write it out, look for pairs. 1, 2 pairs. That's going to be x squared. There's 2 pairs. And this guy is left over, so he stays underneath. That is your answer, which was D. All right, number 2, which of the following shows 3 radical 2 squared, completely simplified? Again, off to the side here, let's work this out. If you square something, you guys, that means you multiply it by itself. So you have to write this twice and then multiply it. So if the parentheses distract you, you don't even need them. Let me get rid of those. You technically don't need them. Just realize that you're multiplying here. So basically, your answer is going to have a radical, at least to start. You can multiply the numbers on the outside to get your new number outside. You can multiply the numbers underneath to get your new number underneath. So I'd have 9 radical 4. You always want to step back. What's under the radical? If that can be made better, you should do that. And the square root of 4, you guys, is just 2. That's a perfect square. So you're multiplying those two things. This is really just 9 times 2, which is 18. Number 3, which of the following could not be combined to make a single term? Do not look over the word not. All right, I notice that all of them are adding and subtracting, and I know I can only add them together if they are like terms, like radicals. So number 1, you can add those together because they both have a radical 6. So that would be 5 radical 6. So it's not A. The others, at first glance, look like, well, I don't think I can do any of those. But look closely. If you look at D, 25 is a perfect square. That's just 5. 16 is a perfect square. That's just 4. So this guy equals 9. I can put those together. It's not D. Now I have to dig a little bit deeper for B and C. So maybe off to the side, let me just see if I can break down any of the radicals in B. Okay, so what I mean by that is if you broke down 3, okay, that's not going to go anywhere. There's no pairs. So that's just 4 radical 3. That's as simple as it gets. But look at 12. There's going to be a pair of 2s when I break that down. So I can rewrite that. I can make that better. Here's what it's going to look like. There's a 2 already out there. And then you got a pair of 2s. So a 2 comes out. That 3 stays under. Bring down my plus sign. This is the same thing as just 4 radical 3 plus that other 4 radical 3. Those are both radical 3s. That's 8 radical 3. I can put those together. So it's not B. I'm not going to waste my time doing C and breaking that down. The answer is C. If you did break this down, you guys, it ends up being 2 square root 7 plus 7 square root 2. And the radical number is different, so you cannot combine those, which is what they wanted to know. Number 4, this one was extra credit. Let me show you how to do this so you can earn your extra credit on the retake. The question says find the area. Here's the formula. Base 1/2 base times height. Now, this is the base, you guys. This is the height. I need those two things so I can calculate my area. We have the base is 4 right here. I just need the height, so I have to figure that out. To figure that out, you use Pythagorean theorem. If it's a right triangle, you use Pythagorean theorem to find a missing side. So let's do that work here. A squared plus B squared equals C squared. C is the side across from the right angle. 6 is your C. That's the one that matters. Doesn't matter for the other two. I'm just going to do H squared plus 4 squared. Okay, squareds first. So that's 16. 6 squared's 36. Then I'm going to subtract this 16 over, and I am definitely going to run out of room, so I'm going to bring it up here. Sorry. A lot of arrows. But here's where I'm at. H squared equals 36 minus 16 is 20. So now I need to square root to get rid of the squared. So H equals, I'm going to have to do a factor tree. Let's get rid of that. I'm going to have to do a factor tree on the 20 because they do say they want me to leave my answer in simplest radical form. So let's do like 4 and 5, 2 and 2. Okay, so a 2 would come out, 5 would stay under. There's my height. Let's kind of get rid of some of this just for the sake of calculating the area. As you can see, this one's kind of a lot of work. It's like a two-step process. Find the height, then find the area. So height is 2 radical 5 right here. So that's what I'm going to put here to calculate my area. Now, when you calculate this and you leave it in simplest radical, you guys, you basically just don't put the radical 5 in your calculator. You just kind of like tack it on at the end. You're going to do half of 4, which is 2, times 2 would, oops, not 4, would take you right back to 4, sorry. Half of 4 is 2, and again, you can just put in your calculator. Half times 4 is 2, times another 2 would give me 4. Stick the radical 5 back on. This is my area. So it's D. That was bonus. Hopefully you got it. If you did not, try to get it on the retake. Every little point helps. All right, on to the second page, number 5, and all of these have the same directions. 5 through, 11 have the same directions. It says simplify, make the radical, make this expression I'm looking at better, make it look nicer. All right, so what I'm gonna do here is just do a factor tree on number 5. This one should be pretty straightforward. Okay, so I can break this down into like 25 and 3. Doesn't matter if you use something different. Either way, you should get 5, 5, and 3, so let's rewrite it. Okay, pair of 5s, 5 comes out, 3 stays under. So that one's 5 radical 3. On number 6, now, you guys, you can multiply anything. It's adding and subtracting that you might not be able to do the problem. I can multiply these together, and I want to make it one radical to start, so here's how I do that. I can multiply the numbers on the outside to get my new number on the outside. I can multiply numbers underneath to get my new number underneath. So 10 radical 18, that's not wrong, but it's not completely simplified. I can make this better. I can break down the 18. You should always check to see if radicals can be broken down. If there's any pairs that can come out, it's not completely simplified. Okay, and I see a pair of 3s there, so let's get my answer going. Do not forget that this 10 was already out there. Bring it down and then say, oh, there's a pair of 3s. 3 comes out, 2 stays under. I'm going to clean this up. 10 times 3 is 30, radical 2. That's your answer to number 6. For number 7, we've got variables going on this one, but I'm going to break down the 63. So let's maybe do 9 and 7. 7's prime, 3 and 3. Get my answer going. Okay, pair of 3s. 3 comes out, 7 stays under. If you missed the variables, this is what I would do. X's, that's just x times x times x. If it's x to the third, 1 pair. 1 comes out, 1 left over, 1 stays under. The y's, y squared is just y, that's 1 pair, so 1 comes out, no leftovers. Quite colorful, you guys. That's the answer to number 7. Number 8, they keep getting like a little bit messier and messier, if you haven't noticed. So number 8, here's what I do. I'm going to start the answer because I know if I don't bring this negative 6a down, there's a good chance I'm going to forget about it. So I start my answer right away. Then I do a factor tree. Let's do a different color. And the only reason this isn't simplified, you guys, is if there's anything under the radical that's a pair, it can come out front. So I just got to check on all that. 10 breaks down to 5 and 2, no pairs. So 10 cannot be simplified. A's though, so a to the 4th is a, 4 A's. I've got 2 pairs, so that's going to be a squared that come out, no leftovers. Of course, there's an easier way to do b to the 11th, but I'm assuming if you're watching this, you maybe missed that, so my advice is to write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's super extra. Okay, 1, 2, 3, 4, 5 pairs of B's. B to the 5th comes out. This guy's left over. Clean this up on the outside. So here's my final answer. I've got negative 6. These A's, add them together, the exponents. You've got 1 plus 2 more, A3, B5, square root 10B. That is your final answer on number 8. Number 9, if they're multiplying radicals, multiply them together first. You guys make it one problem, then try to make it look better. You can multiply numbers on the outside. Negative 7, that would just be a 1. So that's negative 7. You can multiply stuff underneath. Okay, 3 times 8 is 24. To bring the y's together, you would add the exponents. So this is y to the 1, this is y to the 3. When you multiply those, that's y to the 4th. Now this looks really similar to number 8. So I'm going to start my answer. I'm going to bring negative 7 down. I'm going to factor tree 24 to see if anything can come out front. So I got 2 and 2, 3 and 2. Okay, I've got a pair of 2's, so 2 comes out. This 3 and this 2 stay under. And then let's do the y's. So y to the 4th is y, 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 y. I've got 1, 2 pairs. Y squared comes out, no leftovers. Now just clean it up, make it look a little bit better. I'm really getting colorful here. That would be negative 14, y to the 4th. Underneath the radical, 3 times 2 is 6. There's your final answer. All right, number 10 starts us off with the fractions. Yay! All right, first step for fractions. Remember we gave you some steps for these. Follow them. We said look for perfect squares, even exponents. This one doesn't have either. So then we said to reduce the fraction. 5 over 20, you guys. Start with the number. I can divide both of those by 5. That would be 5 divided by 5, 1. 20 divided by 5, 4. So this is just 1 over 4. Those are both perfect squares, so this is ideal. To bring the ends together, you subtract the exponents. Top minus bottom, 9 minus 1 is 8. Put that on top. So that's n to the 8. Okay, this is great. I'm going to even ignore that 1 because whatever, square root of 1 is 1. That's not going to do anything. But this is perfect now, so I'm going to break up the radical, give the top its own radical, give the bottom its own radical. I have even exponents and perfect squares, which is exactly what I want to make the radicals go away. On the bottom, the square root of 4 is just 2. On the top, n to the 8th, if I wrote this out, I've got 4 pairs, no leftovers. So n to the 4th on top. I don't have to do a factor tree. The final answer is n to the 4th over 2.